All right, let's talk about one of the toughest questions in the entire tech world. It's the one that can make or break a project before anyone even writes a single line of code. How much is the software actually going to cost to build? It sounds simple, but as we're about to see, it's anything but. So let's just dive right into the core of it. I mean, from the newest developer all the way up to the CEO, pretty much everyone has felt the pain of this. Why is it so incredibly hard to put a price tag on a piece of software? You've definitely heard the stories, right? A huge project, maybe it was supposed to take 6 months, and then 2 years later, it's finally done and costs double the original estimate. This isn't just a string of bad luck, it's something fundamental about the nature of software itself. And this, right here, gets to the heart of it. Unlike a house or a car, you can't see it, you can't touch it, you can't really measure it while it's being built. It's intangible. And because it's this web of complex, interconnected parts, it's also intractable. It's just really, really hard to control and pin down. That makes trying to scope it out from day one a massive challenge. This whole thing creates a crazy paradox that makes the problem even worse. We often jump into building without really analyzing the process. And the real complexity? Well, that only shows up way down the road. Here's the kicker. Your most accurate estimate is on the day the project is finished. But of course, you have to make all the big decisions about money and hiring right at the very beginning. So, okay, if it's this difficult, how do the pros even begin to tackle it? Well, it's not a total shot in the dark. They start by breaking the problem down and looking at the key things that are known to drive up the cost. And these are really the big ones. First, you've got to consider how complex the product is. Then, there's just the sheer size of the thing. And this is huge. What's the experience level of your team? Are they seasoned veterans or a bunch of newcomers? What's the timeline we're dealing with? And what kind of tech are we using? Every single one of these can swing the final costs in a big way. But there's one that's kind of the foundation for all the others. And that's the project's size. This is basically the bedrock of almost every modern estimation model out there. Before you can figure out how long it'll take or how much it'll cost, you have to find a common language to agree on just how big this thing is. So, if software is intangible, how on earth do you measure its size? This is where we get into the science part of all this. The industry has really come up with two main ways of trying to quantify this totally abstract idea. And there are really two competing philosophies here. On one side, you've got lines of code, or LOC. Think of that like counting the number of bricks you need to build a house. On the other side, you have function points, or FP. That's like measuring what the house does, how many bedrooms, how many bathrooms. LOC is all about the developer's effort, while FP is all about the value the user gets. It's a really important difference. Let's look at lines of code first. It's a pretty simple idea, right? But since we're estimating, we can't know the exact number ahead of time. So planners use this really clever formula. They come up with an optimistic number, a pessimistic one, and a most likely number. By giving that most likely guess a lot more weight, they get a much more balanced and realistic forecast for the project size. Now, the function point method is a bit more involved, but its huge advantage is that it doesn't matter what programming language you're using. It's a very systematic process. First, you literally count the features, how many screens, how many buttons, how many reports. Then, you go through a checklist of 14 questions to figure out the overall complexity. And finally, a formula mixes those two things together to give you one single number for the functional size. Okay, so we've got a number for size. It's either in lines of code or function points. So, now what? The next step is to plug that number into a predictive model. This is how we finally get the answers we've been looking for. How much effort is this going to take, and what's the final cost going to be? And one of the most famous models for this is called COCOMO, the Constructive Cost Model. It's an algorithm that takes the project's size, in thousands of lines of code, and uses that to estimate the effort needed in what's called person months. That's just a simple way of saying one person's work for 1 month. Now, here's what makes COCOMO so smart. It knows that writing 10,000 lines of code for a simple payroll app is a totally different ballgame than writing 10,000 lines for, say, airplane flight control software. So the model forces you to first classify your project into one of three types. This table lays it out perfectly. On one end, you have organic projects. They're usually smaller, not too complex, with experienced teams. Think of a simple payroll system. In the middle, you have semi-detached, which are bigger and more complex, like an operating system. And then you have the big ones, embedded projects. These are massive, super complex, with incredibly strict rules where failure is just not an option, like that flight control software. Okay, don't let the formula scare you.
All it's saying is that the effort is based on the size, the kilo lines of code. The really important part here are the A and B values. Those numbers change depending on if your project is organic, semi-detached, or embedded. That's how the model accounts for the fact that effort grows exponentially. A complex embedded project takes way more effort per line of code than a simple organic one.
But, the real world is messy. So the intermediate COCOMO model adds another layer of realism. It brings in 15 different cost drivers that tweak the final estimate. This is where you factor in stuff like, how bulletproof does this software need to be? How skilled is my team, really? Are we using the latest tools? This helps fine-tune the estimate and makes it much more accurate. So we've gone through a lot of theory here, measuring size, plugging numbers into models, but let's bring it all back down to earth. Why does going through all this complex modeling actually matter in the real world? The whole point of estimation isn't about finding a crystal ball that gives you a perfect number. It's about changing the conversation from a wild guess into a discussion based on data. These models give you a structured, repeatable way to turn this giant, scary unknown into a calculated, manageable risk. And at the end of the day, it all comes down to this. This is not just some academic exercise. Getting the estimation right is a cornerstone of a successful project. It lets you plan properly, budget correctly, and it sets the entire project up to succeed from the very start. So I'll leave you with a thought about the future. For decades, we've been focused on measuring human effort with things like lines of code. But now, as AI and code generators start writing more and more of our software for us, what does that mean for estimation? If lines of code isn't the main thing anymore, what's the new size we're going to have to measure next?